Welcome to Tomorrow Unveiled, the show where we decode the breakthroughs that'll reshape your world starting today. Something wild just happened. And I don't mean the usual, oh, there's a new model kind of wild. I mean the kind of wild where you look at what the entire AI industry just released in a single month and realize we've hit an inflection point. We've got four frontier models from four different labs, all released within weeks of each other. And here's the thing. They're all solving the problem of intelligence in completely different ways. Claude Opus 4.6, Gemini 3 Deep Think, Kimi Agent Swarm, GPT 5.3 Codex Spark. Four names, four philosophies, one fundamental shift in how the AI industry thinks about what smarter actually means. By the end of this episode, you're going to understand not just what these models do, but why the fact that they all exist. At the same time, all frontier-level capable is going to reshape everything about how AI gets built and deployed. Because this isn't about benchmark numbers anymore. This is about the fracturing of the monoculture. Let's dig in. Claude Opus 4.6 takes Anthropic's obsession with reasoning to an extreme. And I mean that literally. The headline number is this: 1,000,000 tokens of context. That's not a typo. 1,000,000. To put that in perspective, that's roughly equivalent to 750,000 words. It's like handing an AI the complete works of Shakespeare, plus every scientific paper ever written about biology, plus the entire codebase of Linux, all at the same time. And Claude can hold all of that in its mind while reasoning through a complex problem. But here's what's genuinely interesting. It's not just the size that matters. It's what Anthropic did with the thinking process itself. Claude has this feature called adaptive thinking. And here's the thing that makes it different from just thinking harder. The model itself decides how much computational effort to spend on each problem. It's like having a student who knows when to skim and when to deep dive. When you ask it a simple factual question, it doesn't burn tokens on extended reasoning. But hand it a physics problem that requires serious mathematical reasoning, it automatically allocates more thinking time. It's self-aware about cognitive load in a way that's actually kind of unprecedented. Anthropic proved this works by doing something almost reckless. They assembled a swarm of Claude instances, think of them as a team of experts, and had them build a C compiler from scratch. A real compiler. The kind of thing that normally takes human teams months. They spent $20,000 and over 2,000 Claude code sessions to pull it off. And you know what? It worked. They built a 100,000-line compiler that could actually compile Linux 6.9. It even played Doom. Now, the way they orchestrated this is worth understanding because it reveals something about where Agentic AI is heading. They didn't just throw agents at the problem. They gave each agent different roles. Some were engineers, some were testers, some were architects. They offloaded context to external files, so the main agent thread stayed clean. They even injected time markers at random intervals because LLMs are time blind. They don't have a natural sense of duration. So if a task takes a month, the model has no way of knowing unless you tell it. The benchmarks back this up. Opus 4.6 doesn't win everywhere, and that's actually important to note. On pure software engineering benchmarks like SWeBench, it trades spots with GPT 5.2, but on agentic tasks, the kind of work where an AI needs to coordinate, reason, and persist over long sequences of steps, it's substantially ahead. Terminal Bench 2.0 shows a massive jump. Agentic financial analysis? Opus 4.6 dominates. Long context retrieval? No contest. Here's the pricing reality, though. If you're going to use that million token window, it gets expensive fast. $5 per million input tokens, 25 per million output tokens. If you're really pushing it, the costs climb. But what you're buying is something that didn't exist before. A model that can genuinely hold and reason about massive amounts of context while deciding intelligently how hard to think about each subproblem. That's Anthropic's play. Thinking engines. Models that are good at reasoning, at planning, at breaking down complex problems into parts. They're betting that the future of AI is cognitive depth, not breadth. Google looked at the same problem and asked a completely different question. Gemini 3 Deep Think isn't trying to be the most generally capable model on the planet. It's not chasing the highest score on every benchmark. Instead, Google built something almost radically focused, a model that's obsessed with scientific reasoning. Here's the core insight. Google realized that not every task needs extended thinking, but some tasks need it desperately. Physics problems, chemistry, advanced biology, the kinds of problems where you need to explore multiple solution paths, check your work, and reason through complex causal chains. So, what's Gemini 3 Deep Think actually doing? When it encounters a hard reasoning problem, it engages a mode Google calls deep thinking. It's similar to Claude's adaptive thinking mechanically, but the philosophy is different. Google's saying, we're building a model that's exceptional at scientific reasoning, and we're willing to trade some general capability to get there. The results speak for themselves. On GPQA Diamond, which is basically the hardest science questions you can throw at an AI, questions where even experts get them wrong, Gemini 3 Deep Think hits 91.9%. On ARC AGI 2, which tests fluid reasoning and pattern recognition, it scores 45% with deep thinking engaged. These aren't the highest scores ever, but they're state-of-the-art for reasoning-focused benchmarks. What's genuinely interesting is that Google isn't hiding the trade-off. They're being explicit about it. Deep thinking doesn't make you better at everything. It makes you better at the things that actually need deep reasoning. If you're asking a model to summarize a document, deep thinking is wasted computation. If you're asking it to design a novel protein or debug a complex physics simulation, that's where it shines. And here's what's actually important. This is a bet on specialization. Google's essentially saying, the future isn't about one model that's good at everything. It's about models that are exceptional at what they're designed for. You use Gemini 3 Deep Think for scientific reasoning. You use a different model for creative writing or customer service. The practical implication is that Gemini 3 Deep Think is available now, and it's integrated into Google's ecosystem. If you're a researcher or engineer working on hard scientific problems, this model is available to you. It's not a theoretical future, it's deployed. But here's what that means for the broader market. Google just signaled that the monoculture is over. They're not trying to build the one model to rule them all. They're building the model that rules in their domain. While Anthropic and Google were building thinking engines, a Chinese company called Moonshot figured out something wild. What if you didn't need one genius AI, but a team of specialized ones? Kimi K25 introduced something called Agent Swarm, and it's genuinely a different architectural approach than what we've seen before. Here's how it works. Instead of one AI doing all the thinking, you have multiple agents with different specializations that coordinate with each other. One agent might be great at data analysis, another's optimized for code, a third handles research. They don't report back to a central orchestrator like subagents do. They actually interact with each other directly. They share resources. They collaborate. It's like the difference between having one person try to do everything versus having an actual team where people can work in parallel and bounce ideas off each other. Kimmy K25 itself is a trillion-parameter open-source multimodal model. That's the foundation, but the real innovation is the swarm architecture on top of it. You can spin up multiple agents, assign them different roles, and they'll coordinate to solve problems that would normally require either one super smart AI or significant human direction. What's interesting is the practical applications. You could have one agent handle data collection, another do analysis, a third generate reports. They're all working simultaneously, and they're not stepping on each other's toes. It's genuinely collaborative in a way that changes how you think about agentic AI. The benchmarks show this pays off. On tasks that require coordination, like complex research workflows or multi-step analysis, Kimmy's swarm approach outperforms single-agent approaches. It's not about having one smarter agent, it's about having the right team. Here's what's genuinely wild about this. Kimmy is open source. That means researchers and companies can take this architecture and build on it. You can customize it. You can run it yourself. This is fundamentally different from Claude or Gemini, which are closed commercial products. The trade-off is that Kimmy doesn't have quite the raw capability that Opus 4.6 or the latest GPT models have on pure benchmarks. But that's not the point. The point is that Moonshot bet on a different model of intelligence, collaborative, distributed, open source. And they're proving that approach works. What this signals for the market is that the architecture of AI is up for grabs. It's not just about having a bigger model or a smarter model. It's about how you structure intelligence. Monolithic, distributed, swarms. All of those approaches are viable now, and they're all frontier level capable. OpenAI just did something that nobody's talking about, and it might be the most important move in this entire wave of releases. GPT 5.3 Codex Spark isn't just a new model. It's a new model running on completely different hardware, Cerebrus chips. And here's why that matters. Inference speed and cost fundamentally change how AI gets deployed in the real world. Codex Spark is specifically optimized for coding tasks. The name itself tells you the bet OpenAI is making. This is about the spark of creativity in code generation, about speed, about making coding AI practical at scale. The benchmarks are compelling. On Terminal Bench 2.0, which tests real-world command line tasks, GPT 5.3 Codex Spark hits 64.7%. That's competitive with Opus 4.6. On SWE Bench, it's right in the conversation. But here's the thing. It's doing this while running on specialized hardware that's orders of magnitude faster for inference than standard GPUs. What's genuinely interesting is the hardware angle. Cerebrus makes chips specifically designed for AI workloads. They're not general-purpose processors. They're built from the ground up for inference. And pairing a frontier-level model with frontier-level inference hardware creates this weird new category. A model that's not just capable, but fast and cheap to run at scale. That changes the economics of AI deployment. If you can run a state-of-the-art coding model at a fraction of the cost and with a fraction of the latency, suddenly you're deploying it in production systems you wouldn't have touched before. Real-time coding assistance, automated debugging, continuous integration that's genuinely intelligent. Here's what's actually important. OpenAI is signaling that the next frontier isn't just raw capability. It's practical deployment. It's taking models that are already frontier level and making them actually usable in real systems. That's a different kind of innovation, and it's the kind that actually changes how software gets built. The timing is also not accidental. Codex Spark came out right after Opus 4.6. OpenAI is essentially saying, yes, we're competitive on capability benchmarks, and also, we're thinking about implementation in a way the others aren't. Okay, so here's what just happened. We've got 4 different models from 4 different labs. They're all frontier-level capable. They're all solving the problem of intelligence in different ways. And they all shipped in the same month. That's not a coincidence. That's a signal. For the past few years, the narrative was simple. One model to rule them all. GPT-4 was the best. Then Opus 3.5 was the best. Then it was a close call. Now, it's genuinely complicated because best doesn't have a single meaning anymore. Claude Opus 4.6 is best if you need reasoning depth and long context capability. Gemini 3 Deep Think is best if you're doing scientific reasoning and you want a model built for that. Kimmy is best if you want collaborative intelligence and open source flexibility. Codex Spark is best if you need coding capability deployed at scale with minimal latency. They're not competing in the same space. They're competing in different spaces that happen to overlap. Here's the uncomfortable part. This is only going to accelerate. We're going to see more specialized models. We're going to see more architectural experiments. The monoculture is breaking, and that means the market is fragmenting. For developers and companies, this is actually good news. You've got options, real options, not just different price points on the same product, different fundamental approaches to intelligence. But it also means you have to think harder about what you're building. If you need pure reasoning capability, Claude is the play. If you need speed and cost efficiency, Codex Spark. If you need collaboration and open source flexibility, Kimmy. If you need scientific reasoning, Gemini 3 Deep Think. The era of one model doing everything decently is ending. The era of multiple models doing specific things exceptionally is beginning. Hey, real quick. If you're enjoying this breakdown, do me a favor and hit that subscribe button. And turn on notifications so you don't miss the next episode when it drops. Now, we have to talk about the elephant in the room, because all four of these models are dramatically more capable than anything we had a year ago. And that raises real questions. Anthropic released a system card for Opus 4.6 that's over 200 pages long. It's probably the most comprehensive safety evaluation we've seen for any frontier model. And here's what it found. Opus 4.6 is well aligned. The rate of misaligned behavior is comparable to its predecessor, but there are some findings that warrant attention. The model is sometimes overly agentic in coding and computer use settings. It'll take actions without asking permission first. It's got an improved ability to complete suspicious side tasks without triggering automated monitors. None of this rises to the level of being concerning, but it's worth watching. Gemini 3. DeepThink's safety profile is similar. Google tested it extensively. It's safe to deploy, but they're transparent about the fact that deep thinking mode can sometimes lead to more creative, and occasionally more concerning, solutions to problems. Kimmy, being open source, puts the safety burden partially on whoever deploys it. That's actually a feature for some use cases and a bug for others. You get more control, but you also get more responsibility. Codex Spark is purpose-built for coding, which actually simplifies some safety considerations. You're not asking it to reason about harmful requests. You're asking it to write code. That's a narrower attack surface. Here's what's genuinely important. All four labs are taking safety seriously. They're evaluating these models rigorously. They're being transparent about limitations. But they're also deploying them, because at some point, you have to make a judgment call about whether a model is safe enough to release. That judgment is getting harder. These models are so capable that evaluating them is almost as hard as building them. Anthropic actually used Opus 4.6 to debug its own evaluation infrastructure. That creates a weird loop. You're using the model to evaluate the model. How do you know you're not missing something? The honest answer is you don't. Not completely. But all four labs have decided the risk is acceptable if you deploy thoughtfully. With safeguards, with monitoring, with the willingness to intervene if something goes wrong. That's not perfect, but it's the best we can do right now. If we zoom out and look at where this is heading, a few things jump out as almost inevitable. First, specialization accelerates. We'll see more domain-specific models. We'll see models built for medicine, for law, for scientific research, for creative writing. The era of one-size-fits-all is ending. Specialized models are winning in their domains, and that trend only intensifies from here. Second, the hardware-software co-design matters more than it ever has. OpenAI's move with Cerebras isn't an outlier, it's a preview. We're going to see custom silicon built for specific model architectures. Inference speed becomes a competitive advantage that's as important as raw capability. Third, agent coordination becomes table stakes, meaning every major model will need it to stay competitive. Anthropic's agent teams, Kimmy's swarms. That's the direction everything's moving. Monolithic models are still useful, but orchestrating multiple agents to solve complex problems is where the real power is. Fourth, the open source versus closed trade-off is real, and it's not going away. Kimmy shows that open source models can be frontier-level capable, but closed models can move faster and iterate more aggressively. Both approaches have advantages. We're going to see both, and they're going to push each other. Fifth, evaluation infrastructure is becoming a bottleneck. All four labs are struggling with the same problem. How do you evaluate models that are smarter than your evaluation infrastructure? This is genuinely hard. We're going to see investment in better benchmarks, better evaluation methods, and frankly, more reliance on expert judgment. And sixth, the cost-capability frontier is shifting. It's not just about how smart the model is. It's about how much it costs to run it, how fast it is, how easy it is to integrate. Those factors are becoming as important as raw benchmark scores. If you're a developer or a company building on top of these models, this is actually good news. You've got options. You can choose the model that fits your problem, not the other way around. If you're thinking about the future of AI more broadly, this is the moment where the monoculture breaks. We're not going back to one model being the answer to everything. We're moving into a world where intelligence is diverse, specialized, and distributed. Oh, and if you're watching on your phone, there's a hype button right below the video. Hitting that really helps smaller channels like ours get discovered. Here's the thing that keeps me up at night in the best possible way. We're watching intelligence become a commodity, not in a bad way, in a way that's actually democratizing. Anthropic open-sourced Claude earlier this year. Moonshot's Kimmy is open source. OpenAI's making coding models more accessible. Google's deploying DeepThink widely. The barrier to entry for building on top of frontier-level AI is collapsing. You don't have to be a massive company to access state-of-the-art intelligence. You can use an open-source model. You can use an API. You can specialize a general model for your use case. That's a fundamental shift. For most of AI history, frontier capability was locked behind closed walls at a handful of companies. Now? Now it's proliferating, and the competition is forcing everyone to be better, faster, cheaper. But here's what's worth thinking about. With that democratization comes responsibility. If everyone can access frontier-level AI, then everyone needs to think about how they're using it. Safety isn't something that happens in a lab anymore. It's something that happens at deployment time, at the point where someone uses a model to build something in the real world. That's harder. That requires more vigilance. That requires a different kind of governance. But it's also the only way forward. You can't keep AI capability locked up forever. Eventually it gets out. Eventually it gets used. The question is whether we're thoughtful about how. What we're watching right now, with Opus 4.6 and Gemini 3 DeepThink and Kimi and Codex Spark all shipping in the same month, is the beginning of that transition. We're moving from the era of AI labs to the era of AI everywhere. These four models are the preview of what that looks like. And honestly, it's exciting, it's scary, but mostly it's exciting. There's this moment in the history of technology where you can see the inflection point happening in real time. When the transition from one era to the next becomes visible, this is that moment. So here's what we know. Four models, four different philosophies, all frontier-level capable, all shipping in the same month. Claude Opus 4.6 is betting on reasoning depth and long context capability. Gemini 3 DeepThink is betting on specialization in scientific reasoning. Kimmy is betting on collaborative, distributed intelligence. Codex Spark is betting on practical deployment at scale. They're all right, and they're all going to matter. The future of AI isn't about finding the one best model. It's about having the right model for the right problem. It's about orchestrating multiple models. It's about specialization. It's about speed. It's about cost. It's about open source versus closed. It's about all of those things at once. If you're building something on top of AI, you've got more options now than you ever have. You can choose based on your specific needs, not just on hype or brand. That's genuinely new. If you're thinking about the future of the industry, what you're seeing is the fracturing of the monoculture. And that fracturing is actually healthy. It's pushing everyone to be better. It's pushing innovation in different directions. It's preventing any single company from having too much control over the future of intelligence. That's worth celebrating. Thanks for hanging with me through all of this. If this episode hit for you, consider subscribing. Share it with someone who's thinking about AI. And let me know what you think. Which of these models are you most excited about? What problem are you trying to solve with AI? The conversation's just getting started. Until next time, stay curious. The future's being built right now, and it's more interesting than you think.